Alright guys, welcome to lesson 3 of unit 6. Today we're going to talk about dividing polynomials. We've talked about multiplying them, we've talked about factoring them. And factoring really is a kind of division, but today we're going to learn two other kinds of division that you could do with polynomials. One of them is known as long division, and the other one is known as synthetic division. Synthetic, it only works for certain kinds, but it's basically a shorter way to do the long division. So we want to know both strategies since long division works on more stuff, but we definitely want a synthetic because it's faster. Alright, let's go ahead and take a look at a basic old school long division problem that we haven't seen in a little while, and just kind of review that process. So first of all, you got to set it up, right? The 684 goes underneath of the bracket, and the 5 goes out here. We call this number here the dividend because it's the one that's being divided, and we call this one the divisor because that's the one that's doing the division. Okay, so what we do is we ask ourselves, how many times does this number go into this number? And the answer is once. And then we do 1 times 5, right? And that gives us 5, and we put that underneath, and then we subtract. That leaves us with 1, and then we bring the rest down. Now we ask ourselves, how many times does 5 go into 18? Well, 5 goes into 18 3 times, and then we do 3 times 5 to get 15, and then we subtract to get 3, and then we bring the next number down. How many times does 5 go into 34 now? That would be 6 times to make 30. Subtraction leaves us with 4, and then we write our answer. You have this, which is what's called the quotient, and then you have this, which is known as the remainder, and you put that over the original divisor. And so it's quotient, remainder. I'll put D for divisor, even though there's two D's up here. That I'm using the capital D to represent divisor. Okay, and so that's long division as we've learned it back in grade school. And what we're actually going to be doing something quite similar today. We're just going to be doing it with polynomials. So let's go ahead and jump in. You probably saw this in Algebra 2, but if not, you'll see it today. All right, let's begin here. So first thing we want to do is we want to take the first term, which is the dividend, and we're going to put that in the brackets. And then we're going to put the divisor, which is the second polynomial there, outside. All right? So that's your setup. And now we're going to do pretty much the same thing.
Mr. Bailey?
All right. And so after we've got our setup, we're going to go ahead and we're going to ask ourselves, what would I have to, well, how many times does this go into this? Okay. Another way you could ask the question is, what would you multiply x by to get 6x cubed? But if we just divide them over here, I'm going to show my work on the side, you end up with 6x squared. And so x goes into 6x cubed 6x squared times. Okay? So I just take the one on the inside there, and I divide it by the one on the outside. And I put the result up on the top there. Now the next thing I'm going to do is I'm going to multiply this 6x squared. Oops. Multiply that 6x squared times both numbers here, the x and the 1. So 6x squared times x is 6x cubed. And I'm going to put that right there. And then 6x squared times 1 is just 6x squared, and I'm going to put that there. Notice how I'm lining up the like terms. I've got the cubes lined up with each other, and I have the squares lined up with each other. All right? So let me erase my little arrows here, get these out of the way. So step one is I ask myself, what do I have to multiply x by in order to get 6x cubed? Or in other words, what's 6x cubed divided by x? And I got 6x squared. Then you multiply that by both numbers and put it underneath. And the next thing we're going to do is we're going to subtract these terms. So I'm going to put a bar here, and I'm going to minus and minus. And it just changes their signs. So now these cancel out, right? And then the next one is we have 3x squared minus 6x squared. Now that's going to be minus 3x squared. Guess we'll keep it red, why not? Minus 3x squared. And then we bring down the new term. As you guys can see, these steps are all very similar to the regular old long division that we do. So now we're going to repeat. So now I want to ask myself, what would I multiply x by to get negative 3x squared? Or another way you could do it is just think, okay, what's negative 3x squared divided by x? And the answer is negative 3x. And that's what's going to go up here on the top. All right, now I'm going to take that negative 3x squared, I'm going to multiply it times both of those and put my answers here and here. All right, so negative 3x times x is negative 3x squared, and negative 3x times 1 is negative 3x again. And now what we do is we subtract it, right? So I'm going to go through and subtract these. So since they're already negative, when I subtract them, they're going to become positive. So we just change the signs. That cancels out. Negative 8x and 3x makes negative 5x. Bring down the negative 6 and repeat again. All right, so now what would I multiply x by to get negative 5x? That one's a little bit easier just to do mentally. That would be negative 5, right? So now I'm going to take my negative 5 and multiply it times both of these numbers and put it here and here, right? All right, so multiplying negative 5 times x, I get negative 5x, and multiplying negative 5 times 1, I get negative 5. And then we go through and change the signs again because we're going to subtract the whole thing. So this becomes a plus, and that becomes a plus. These cancel, and I'm left with a negative 1. Now, as soon as the number that you get here has a power that's less than this number, then you're good to go. In other words, you're done. Okay? So, since that's just a number and it doesn't have an x, that has a power less than x, which has a power of 1. So, there's our answer. Now, how do we write our answer out? Well, the same way we did on the other regular long division problem. You write your quotient first, and then you do your remainder over your divisor. So my quotient is 6x squared minus 3x minus 5. And then my remainder is negative 1. And my divisor is x plus 1. Now, usually they'll put a little plus sign here in between this, which is something we don't usually do when we're just working with just numbers. But with polynomials, we do. And actually, since we're adding a negative, what you'll find they might do is they might actually just take that little negative on the top and move it down here and make it a minus instead. But either way is fine. You can either put plus a negative 1 or you just put minus 1. But there's our final answer. Okay? So it's just a repeated process of division, multiplication, subtraction, repeat. Divide, multiply, subtract, repeat. Okay, so let's go ahead and do a guided practice here. I think I set up a guided practice, yeah. Okay, so first of all is the setup. So we want to get our setup correct. The first thing you guys want to make sure that you know how to do is how to set it up. So go ahead, pause the video here and see if you guys can accurately set this thing up. Alright, so here's the setup. You have the polynomial x to the 5th minus 3x to the 4th, etc. underneath of the bracket. And then you have the divisor, which is x squared minus 1 on the outside. Now, on this problem, I'm going to introduce something new that wasn't on the last problem. When you're doing long division, you need all of your like terms to line up. so that way you can combine them together. Remember how we had numbers here and here, and then we combined them together, etc., right? And that gave us a new term here and here. Well, if your like terms don't line up, then you're going to have a problem. So in order to get all the like terms to line up, we kind of need to make sure that every term is accounted for. Now, what do I mean by that? Notice this thing starts with a 5th power. The next power down is a 4. The next power down is a 3. Now, this one is actually missing a power of 2, isn't it? So we need to fix that. And here's how you do it. I can put a power of 2 in there if I just put a 0 in front of it. Because 0 times anything is just 0. So it's like I'm adding 0. But the difference is that it's a placeholder. So now I have a place to put my x squareds if I want to. After that we have a 4x, which is an x to the 1st power, and then you have a 1, which is no x at all. So you need to have every term accounted for. Another thing is that has to apply out here to the divisor also. So notice that my divisor starts with a power of 2. So I'm going to start there. But what should come after a power of 2? Well, a power of 1 should. But we don't have an x to the 1st power in here. So I need to put a 0x in there. Okay, so when you're doing long division, part of your setup is to make sure that every term is accounted for. If they don't have one of each of the terms, you need to put them in there with some zeros. Otherwise, it's not going to work out well for you. Okay, so there's the actual setup. So now I'm going to let you guys do the next step. The next step is, how many times does this go into this? Hopefully you guys got x to the 3rd power. How do you get that? You take the x to the 5th, and you divide it by the x squared, and you get x to the 3rd power. All right, now what do we do? Go ahead and pause the video here and see if you guys can come up with the next step. This is what you guys should have gotten next. You should have multiplied that x cubed times all 3 of the terms over there of the divisor, and then put your result underneath of each term that matches it at the bottom. Go ahead and pause the video here and see if you guys could do the next step. Alright, so this is what you guys should have gotten for your next step. You should have changed all the signs in this row here, and then added straight down. The first term should have canceled, and all the other ones, when you combine them, would have ended up being negative 3x to the 4th plus 3x cubed plus 0x squared. Remember to bring down that next term, right? Alright, now the next thing that we do is what? Go ahead and pause the video and see if you could do the next step. The next step is to ask, how many times does x squared go into 3x to the 4th? Or in other words, if I did negative 3x to the 4th divided by x squared, what would I get? And the answer is negative 3x squared. So that's what we're going to put on there next. Erase all my scratch work there. Okay, go ahead and do the next 2 steps. Do the next 2 steps. Pause the video. When you unpause it, you'll see the solution. Okay, so that's where we should have been. You should have multiplied your negative 3x squared, the red one up there on the top, by all 3 of the divisor terms, and then write your answer in there. Change all the signs and combine down. And you should have gotten that. Alright, now what? Go ahead and do the next complete cycle to the point where you're going to bring down the negative 1. So do the next complete cycle where you're going to bring down this negative 1 at the very end. So that's a lot of steps, about 3 whole steps I want you guys to do there. So go ahead and do that. Alright, and that's what you should have gotten that time. You should end up with that blue 3x at the very top, because that's what you would need to multiply x squared by to get the 3x cubed in green down there in the bottom. And then we go ahead and multiply the 3x times all 3 of the terms in the divisor, and you get this, what we have in the 3 blue terms at the bottom. And then we change all their signs, as I did in orange, and then we combine them together, and we get this new orange expression down here at the bottom, and I brought down the negative 1. All right. Now notice that we still get to go again, and we still get to go again because this power is not less than this power. They're equal. When they're equal, that's kind of a good sign that that's going to be your last time of doing it, though. So we do have to do it one more time. So I'll go ahead and wrap it up here. What would I multiply x squared by to get negative 3x squared? Well, that would be negative 3. And then I would multiply that by all three of these, and I would get 3x squared, negative 3x squared, minus 0x, and then, oh, this was supposed to have, these are both supposed to have x's on them. I goofed up a little bit there. And then negative 3 times negative 1 is positive 3. And then I'm going to go through and change all the signs there, so it becomes a plus, and a minus. And so this cancels, and I'm left with 12x minus 4. And since I have an x now, which has a power less than x squared, we're done. And so we can actually write out our final answer here. My final answer is the quotient, which is everything on top, x cubed minus 3x squared plus 3x minus 3. And then plus my remainder, which is 12x minus 4 at the very bottom there, over my divisor, which is x squared. We don't need the 0 in our final answer, so I'm not going to put the 0x in there. And that's our final answer there. All right, so that's long division. So we've done a student practice, or I mean a guided practice, and I kind of want you guys to be able to do a student practice now, one where you completely work on your own. So go ahead and do this problem, but before you begin, once again, make sure that you have all the terms accounted for. This one's missing an x squared, so we'll need to fix that. But I think that's all that's missing. So go ahead and do this one. Pause the video, and when you unpause it, you'll see the solution. All right. And so there's our answer for your student practice. Now that's long division. And you could do long division with any kind of polynomials you want to. But it would be nice if it didn't take so long. And someone actually came up with a nice little strategy for dividing polynomials called synthetic division. But the limitation of this method is that it really is only going to work for problems where you have x plus a or x minus a as the divisor. So if you don't have just a first degree binomial down here, then unfortunately this little strategy I'm about ready to share with you won't work. But it's a lot faster. Okay? And so if you do have that, which by the way is the one that we use most often, it's nice to know. It speeds things up. Now first of all, synthetic division though is a lot like long division in that you need all terms accounted for. So I am missing a square, so I need to put a square in there. But other than that, it's going to look quite different. All right? So here's how this works. Okay? The first thing we're going to do is we're going to draw a box that looks like this. And what I'm going to do is I'm going to take each of the coefficients, only the coefficients, off of the dividend, and I'm going to put them in here. Okay? Then I'm going to take this number off of the divisor, and I'm going to put it over here, but I'm going to do the opposite sign of that. So instead of a negative 2, it's going to be a positive 2. Okay? And then what we're going to do is we're going to do the following. And that's your setup. So your setup is as follows. Make sure all your terms are accounted for. And then coefficients of the dividend go inside the bracket. Opposite of the constant on the divisor goes on the outside. Okay? Now after you've got your setup, we're going to repeat the same steps over and over. It's going to be add down, multiply, repeat. So let me show you what I mean. Add down, we'll just bring that 5 down. Multiply the 2 times the 5, which is 10. You're going to put your answer right there. And then repeat. Add down, what's 0 plus 10? That makes 10. Then you're going to do 2 times 10, which is 20. And you're going to put your answer right there. Add down, that makes 17. 2 times 17 is 34. Add down, and you get 35. Okay, so it's add down, multiply, add down, multiply, add down, multiply. All right, but what does that mean? Excuse me. But what does that answer mean exactly? Okay, well, here's what it means. This is my remainder, so the last number will always be your remainder. This will always be your constant term. The one after that will always be your x to the first power, and the one after that will always be your x to the second. And if you have more, it keeps going, like x to the third, x to the fourth, and x to the fifth. And so my final answer then is going to be 5x squared plus 10x plus 17. And I'm running out of space here, so just a minute. Let me make some space for myself. Plus 35, oops, plus my remainder over my divisor. So it's much faster, okay? But it's a weird little thing. So just another thing to memorize, but we'll be thankful for that in about another lesson or two where we start using this process a lot. So let's go ahead and do a guided practice with this as well. So the first thing I want you guys to do is I want you to pause the video here and I want you to do your setup. So set this thing up first. Okay, so there's your setup. I didn't have to put any zeros in there this time because all terms are accounted for. It goes 4, 3, 2, 1, and then none, so we don't have to worry about putting any zeros in there. Notice that my 6 is a negative because you do the opposite of this number over here, right? All right, now, what goes here? Hopefully you were thinking 2. Now what do you do? Hopefully you were thinking negative 6 times 2, which is negative 12, and where does that go? Right there. So that would be negative 12. Should put an arrow there. All right. Now I want you to figure out what goes here and what goes here. Pause the video and see if you can get it. All right. So what goes here is 9 and negative 12 put together, which is negative 3. And what goes here is what you get when you do negative 6 times that negative 3, and you get negative 18. Okay? And go ahead and figure out what goes here and here, and then here and here and here. Finish it up and see if you guys can take it home. All right, so negative 28 and negative 20 and negative 18 makes negative 38. Then we multiply negative 6 times negative 38. That's a really big number. 48 and 180. I'm just going to use a calculator. 228. And it's positive though. Add those together, you're going to get 221. Multiply again. 1326 negative. And then add the 19 to that. Sorry the numbers worked out so lame. It happens. But regardless of that fact, let's go ahead and see, what does this number represent? That number represents our remainder. This one represents our constant. What does this one represent? Our x to the first power. How about this next one? Our x squared. And how about the last one? Our x cubed. So why don't you guys see if you can write your answer out the way it should look, the final answer. And when you unpause it, you'll see the solution. All right, there you have it. So let's go ahead and have you guys do a student practice now. Not a guided practice, but a student practice, which means you guys are going to do it from beginning to end on your own. Don't forget to look and see if you have any missing terms. If you do, put zeros in their places. But other than that, I'll let you guys go ahead and try it from here. All right, guys, and there is our final answer. I'll let you study it. Other than that, we'll probably end up calling it a day there, and we'll see you guys next time.